Welcome everyone. The question that is displayed on the question is the question number 20 of the CBSE 2025 physics question set 1. So if you go to the order, okay, that is the short question start from question number 17. Now 17, 18, 18A or 18B and now 19 and 20. So if you go the series of the questions, now it is the question number 20. With the help of the circuit diagram, describe the method to obtain the p-n junction diode characteristics when it is forward biased. Draw the shape of the characteristics. So see question number 17, 18. It is comprehensible, but it is not comprehensible. Actually, CBS is going to ask 50% comprehensible questions. So some questions are comprehensible, some are direct straightforward, and this is the straightforward questions from the chapter semiconductor devices, electronics devices. Okay, so here obviously if you want to show the p-n diode, then obviously the p-n diode you will draw like this. Okay, this is the p, this is the n, and here is the depletion region between the p-n diode. If you want to draw the circuit symbol of the p-n diode, okay, if you want to draw the circuit symbol of p-n diode, it is obviously looking like that. Okay, this side is p and this side is n. So this is the circuit symbol of the p-n diode. Clear? So obviously here P means p-type semiconductor, positive type semiconductor, trivalent impurities are doped there, hole concentration is greater there, and N is the n-type semiconductor, that is the pentavalent impurities doped in the silicon or germanium keyless, and it is negative type, not negatively charged, and obviously here the electron concentration is much more higher than of the hole concentration. So here this one basically this line, it is a depletion region that is merging to impossibilities, because the P here it is the where the hole concentration is very high, and N is where the electron concentration is very high. So this depletion region basically merging to impossibilities. Okay, now what is forward bias? It is the p-n junction diode. So let us draw the p-n junction diode first. Forward bias means if you connect the P side, that the positive side, with the positive terminal of the battery. If we connect the positive side with the positive terminal of the battery like this, and the negative side to the negative terminal of the battery, then we can say this p-n junction diode is forward biased. Okay, this is the forward biased. This is the circuit of the forward biased p-n junction diode. Okay. Now if we try to dive in basic, okay, that is the what is happens if you just connect a junction, a p-n junction diode in forward bias, then what will happen? Obviously from the positive side the holes are entering, okay, and from the negative side the electrons are entering. Okay, then what will happen? Try to understand that. When the p-n junction is just formed in the block diagram, see, when the p-n junction is just formed, here holes are there, but here electrons are there, here electrons are there. Clear? So when this junction is just formed at this here and here, what will happen? Just formed, there is a electron hole pair recombination occurs. Okay, and what will happen on this side, on the p side, electrons are comes from this side. Okay, electrons are comes from n side to p side, and holes are goes from p side to n side. So electron hole pair recombination takes place and depletion region is created. The region which is I have just drawn by a black one, that is depleted of the carriers. Why? Because at the hole and electrons which are the carriers, electron hole recombination takes place. Electron hole recombinations takes place, and what will happen, you know, here let us say this is an atom, okay, and it accepts one electron from the n side, and it becomes now the negatively charged ion, not atom now. Similarly, the atom which is on this side basically leaves that electron okay, and it becomes now the positively charged, and it becomes the negatively charged. So what will happen? A potential barrier is developed. Okay, potential barrier is developed. How? Here on this side you will get positively charged ions, immobile ions which cannot move from this, and here the negatively charged ion. Okay, so what will happen when further electron try to fuse it from this side? It faces this negative potential barrier, and the hole which try to fuse through this depletion region, it faces this positive potential barrier. So further electron hole diffusion stops. Now at this scenario, you connect this PN junction diode with the EMF cell or battery. What will happen? Now from the positive side the holes are fused, and from the negative side the electrons are fused. Okay, just inserted from both of the side. So the hole concentrations on the P side increases, and the electron concentration on the N side increases. So what will happen? This extra electron which comes from the battery basically just captures these positive immobile ions. Similarly, holes which are coming from the P side, coming from the positive terminal of the battery and entering the P side, basically just captures this negatively charged immobile ions on the both sides of the depletion region. So what will happen? Depletion layer width decreases. So after forward bias, if you want to show what is the depletion layer width, the depletion layer width obviously decreases. Depletion layer width obviously decreases. Some is there, little bit is there, but its width is reduced. That's why what will happen? The current flow through the diode increases, okay, and it increases exponentially. It is said that draw the shape of the characteristics, the forward bias characteristics. So if I do this, this is the current along the y-axis, that is the current flowing through the diode, and V, it is the potential through the diode, potential across the diode rather. So it increases, and this is an exponential increase. This is an exponential increase. If I want to write it down, what is the equation for it? The equation is I equal to I naught exponential, that is E, after that EV divided by eta kT. Eta is 1 and 2 for germanium silicon, but here you can see the exponential rise here. Okay, so it increases like this, but here is a voltage which is called the cut-in voltage, that after that this exponential increase starts. Okay, so this is the forward bias characteristics what you need to draw, and this is the circuit diagram what you need to draw. Rest are the things we just dive in the basics, so we just discussed it. Obviously need not to write, but that understanding should be there. Okay, that will help you in solving others questions. Thank you all.